Hey everyone, so today I'm going to take on LeetCode's most famous questions. This is the blind 75 LeetCode list. You see it has like 400, almost 450k views. Is that a million or? Oh, that's 4 million views. Yeah, so it literally has over 4 million views. This list is the most viewed list. This list is the list that everyone does to prepare. So I'm going to try to see how many of these questions I could solve in just 50 minutes, which is what it takes you, or how much time they give you in a regular coding interview. So yeah, pretty much that's what you're gonna see. So I have a timer here, and let's just get started. Let me get through some of the fast ones. To some classic hash map solution. So we just need to print out two indices such that the two indices hit the target. So we can do the hash map solution. We can do the map. And for num in nums, we need to keep track of the index. So enumerate here. If so, what are we looking for? We're looking for a number that if I add that number to my number, we get the target. So what we're looking for is if a numbers that if we take the target and we minus the current number. So if we add it to our current number, we get the target. So if looking for in the hash map, return the current index, and then we'll do looking hash map of looking for, else we'll say hash map of the current num equal to index. That's question one. Question two, best time to buy and sell stock. So we just need to figure out the best time to buy and sell the stock so that we can maximize profit. So pretty much to solve this, you just want to buy at the lowest day and then sell at, you want to figure out what you want to pretty much sell at the lowest date and buy at the lowest day and sell at the highest day. So if we just keep track of the minimum and try to sell at different prices, we could just take the result of that. Yeah, for price and prices, we're gonna return the result, and I'll get to the hard one soon. How much time? We've knocked off a couple minutes for price and price. And price equals do 0 if, or we'll just do result here. For price and price, we'll do result equals, we're trying to maximize, so we'll take the max of the current price, or yeah, the current price minus the minimum price, and then the current result. And then what we're going to do is what's the length of prices? Maybe we could just do prices length, prices of 0, and then we're gonna just keeping track of the min price. So min price and the current price. I think we could just literally do that, and we're good. Contains duplicate. Okay, we're on question 3. We just need to keep track if any value appears at least twice, and return false if every element is distinct. So next guy's coming on in 40 minutes. So we'll do C equals set for num in nums. if num. Sounds good, sounds good. Okay, basically we just need to see if there's any collisions in our hash map, and we return false. Or we return true if any appears at least twice, and return false if every element is distinct. So we can just return false here. But if num is already in the scene, we return true, and then we do scene dot add the number. So if we do something like that, that works. Okay, question 3. Maximums product. This was long prefix someone. Okay, this one's a medium one. Given an integer array nums, return all the triplets. So how many have we solved? 3. Okay, I'll save this one for a second. Let's knock off the easy ones. What do we have here? Reverse a linked list, classic one. So we're given the head of a singly linked list, reverse the list, and return the reverse list. So pretty much we can just start at, so pretty much how are we gonna do this? Don't let me fold on reverse a linked list. We're gonna eventually have to do 2, 1. So 1 will, okay, so if we just keep a left and right, none, and the head, how many elements can we be given? Okay, if head is none, return none. Otherwise we do head equals to left. So what we're gonna do is we're gonna point the right pointer to none. So we'll say while right, and then we'll eventually return the left. But what we're gonna do is while right, we'll do temp equals right dot next. Then we'll go right equals temp. But what we'll do is we'll do right dot next equals left equals right, and then right equals temp. I think that should work right there. How much should we solve? 4 so far? How much? Less than 10 minutes. Detect the cycle in linked list. Yo, chat, count for me. Okay, this is like a fast and slow pointer solution. Head. How many nodes? The number of nodes in the list is 0 to n. If head. So if head is none, return false. So this is a fast and slow pointer. We say while the fast exists and fast dot next. We'll return false if there's a cycle. But if it reaches the end, there's no cycle. But essentially, if there's a cycle, it'll never end. So we just need to figure out when that's gonna happen. So we're gonna say if. So what we're gonna do is we're gonna say fast equals fast dot next. So it's gonna move dot next. Slow is just gonna slow dot next. If fast is equal to slow, if they ever equal the same thing, we would just return there. How many questions is that? 4 or 5? We'll check after. Merge 2 sorted list. Maximum depth of a binary tree. Okay, this one we have to do sort of a post-order traversal. If root is none, return 0, left. So this one we have to do a post-order traversal. And then we have to return. So what's the 1, 2, 3 return? So post order traversal, it'll return us the max on our left and the max on our right. So we'll do self dot max depth of left root dot left root dot right. And then we just say the max of left and right plus 1. Same tree. Let's invert and flip the binary tree first. So we're given the root of a binary tree, invert the tree, return its root. So I think we could just do this. Yeah, we could just do this recursive. We could do this sort of post order traversal. Wait, if I just flip. This is already, wait, how would I do this? So here, I would just flip them here. I think I just have to look at my child and flip them. But will they have to, I wonder if you have to do that in a post order or a pre-order manner. I think we could just, let's try with I think we could just do with a pre-order. So if root is none, we say temp equals root dot left equals root dot right equals temp return root. Can we just do that? Oh no, it doesn't. So we might have to do a post order. Okay, we have to do a post order. Because we have to assume that it's already flipped, and then we just have to flip it. What's happening here? It's annoying how we can't visualize the tree. So then we do post order, these flip. So 2 and 3, these flip. And then it eventually gets flipped. Okay, yeah, we need to do a post order. So we need to do right, left equals self dot invert the tree root dot left. And we'll do the same thing for our right. And then we say temp dot. And I think we could just literally do this. Okay, we have to do a post order to get that working. Okay, now the questions are getting slightly harder. Is it the same tree? Given the roots of 2 binary trees, write a function to check if they're the same or not. 2 binary trees are considered the same if they're structurally identical. So here we could just perform a DFS, like do a DFS simultaneously on the 2 nodes at the same time. 6, thank you. Maybe I'll do one, I can do one after this. So while stack if p if okay, basically what's happening is if they're not the same, if p let's see, yeah, you need to push novos also. So if p is not equal to, if p is none, let's just catch all the cases. Let's be hacky here. If p and not Q or Q and not P, return false. If P is none, just continue. And we could be super explicit here. Continue. If P dot value is not equal to Q dot value, return false. And then otherwise, we just need to push them onto the stack. So what we're saying stack dot append P dot left, Q dot left, stack dot append P dot right, Q dot right, and we'll do P Q equals stack dot pop. Seven. Is this deserialize a tree? Okay. Given the root of a binary tree, return the level order traversal. Okay, level order traversal is easy. So we start with levels here. Chat, how much have I solved now? Return levels. So we're gonna use a queue. From collections import DQ. So we'll use a DQ here. Say while the queue actually exists, for in range of length of the queue, what we're gonna do is if root is none, return empty. And we just need to push the value. Okay, for the level, it's empty. And then at the end, we'll do levels dot append the current level here. And we'll say for this in range, what we do if, we'll say element equals Q dot pop left. Then we'll do level dot append lm dot value. Then we have to put its left and right children. If lm dot left exists, then we do Q dot append lm dot left. Then we need to do the same with the right. Right here. What? For while Q. Oh shoot, I forgot to put the root. Okay. Okay, I'll get to those ones in a sec. Okay, what else? What's one should we do, chat? 8? Holy crap. How much time? 20 minutes? Okay, let's do number of islands, course schedule. So we'll do number of islands. I'm doing the ones that I can knock off fast. For yo chat, is it making sense? This different solutions like 0, you understand it? So what we're gonna need to do is loop through we're gonna return the number of islands here for row. For I in range length of the grid, for j in the range length of the grid 0, what we're gonna do is if the grid at I and j is equal to 1, what we're gonna do is we're gonna perform a DFS on there on the grid. So we'll just write out our own DFS. Self grid row column, and then we'll say what we'll do is we'll do num islands plus equals 1. We'll set the current grid equal, or what we'll do is we'll call the DFS dot DFS on the grid and the row and column. So we'll do is grid on the row and column is equal to 0 to zero it out. And then what we're gonna do is we're gonna loop through our neighbors, and that's gonna be pretty much the row and column here. So we're gonna go up 1, so -1, to the left 1, down 1, to, no, this is to the left, another one was to the right. For nab row, nab column in the neighbors, if nab row is less than 0 or nab row is greater than equal to the length of the grid, continue. Then we need to do the same thing. We need to do the same thing for the column. But if it's greater than equal to this, continue. If the grid row is actually equal to 0, we don't want to recurse, so we just continue, or we just return. Continue. Oh wait, yeah, we continue on sleep. Otherwise we want to perform DFS on that neighbor. We'll do grid. Holy, there's a lot of code. I think that'll work. Wait. What did it return? Output 9. If the grid equals 0. Is this easy? Can you do trapping rainwater? Hold up. I'll get there once I get there. So it's equals to 1. We increase this. We perform DFS. We go on I and j. Row column. Row -1. Column +1. We go row +1. Because I didn't call self. What's it returning now? Is it using the same grid? It's all 0. But why? If holy crap. So the first one, second one. Okay, this, I should just use the stack. I should just use a stack. Should I just switch to a stack? Dude, it's getting hot in my apartment. It's the summer. So exit. Holy, this one's slowing me down. So we exit at 0 and 0. We exit at 0 and 1. Why didn't we loop through the neighbors? This is slowing me down. Why didn't we loop through the neighbors? Should have. Zero and 1. Oh my god, you're right. Got folded. Okay, output limits exceeded. Damn, that was a flop. Thanks, chat. Alex, you're a legend, man. Course schedule. Set matrix zeros. So, bro, this coffee, doing LeetCode, and it's hot outside is making me sweat like crazy. This is so funny. Okay, set zeros. Given if an element 0, its entire row. Given an n by n integer matrix, if an element is 0, set its entire row and column to zeros. You must do it in place. Okay. So there's only 1 0, but here there's 0 0. So I think we just need to keep track of calls to 0 out equals a set. Rows to 0 out equals a set. And then what we just need to do is for I in range length of matrix, for j in range length of matrix. Do we just need, do not return it? Okay, what we need to do is if matrix, and then this right here is the columns. If the matrix at I in j is actually equal to 0, we're gonna say calls dot add j. Then we're gonna say the rows to 0. So we're just gonna keep track of which rows and columns we're gonna 0. Then we can 0 out the different rows. So we can write def 0 row self matrix row. So we say for I in range length of the matrix column. So this is actually j. We do matrix row j equals 0. Make 0 out the column. We'll do column for, so we're saying I for each element in the matrix I. We're gonna stay at a specific column and zero that out. And then we'll just do for call in calls to 0. What we're gonna do is we're gonna zero out the column, self dot zero the column, and we're gonna pass in the matrix, and then 0. How much have I solved so far? Nine? Holy crap. Only? How's that not match any outer? You gotta copy and paste to get these done fast. Valid anagram. Sort. This is not even this one's not optimal, but equals how do we sort this? Let's see. Can you just go like this? Group anagrams. Okay, we just need to figure out the count of each frequency and then throw it in there. Or actually, we just need to sort it, so we need groups for element and string. What we'll do is groups equal the groups of the sorted element we'll do from collections import default dict list groups sorted groups dot append element for key in groups result dot append groups at the key. Join union find would be crazy. Valid parentheses. Okay. How many did I solve so far? Oh, this is classic. Must be closed. Do we need to count this the number of ones of the same? Just the characters. Determine if the input string is valid. An input string is valid if open brackets must be closed by the same type of brackets. Okay. So I think we just need to keep the count of each type. So for if Maybe we could do that in a hash map. Like this. We can just do something like this. We do this. What's the other one? This type. If lm in the type count, do type count lm plus equals 1. Else type count. Dude, I gotta capture all the cases. If lm equals this. Wait, how can we do this fast? Oh, we have to hit all these conditionals. We have to hit all these elif. Yeah, I'm just doing a bunch of the most popular interview questions. Wait, if it's this, then this. Oh, it's backwards. Otherwise, just backwards here. This is gonna be disgusting, but if the type count is less than 0, we'd have to do this. There's probably a way to clean this up, but we're going for speed. What? Oh, because it needs to close. This is not valid? Oh, we had to just use the regular stack approach. Use the regular stack approach. For element in S, if in openings, just do stack dot append the element. Else is closing. So we need to track closing. Then maybe we could do the reverse map here. So for opening, the closing is like this, and then how much time we have left? 11 minutes? Else, if it's a closing, if stack, if length of stack equals to 0, return return false. Else, what we're gonna do, Charlie, you're funny, bro. Else, what we're gonna do is, if the length is stack, otherwise what we're gonna do is, elif stack, the last element is equal to, if it's not equal, if the last element is not equal to closing, oh no, this just needs to map from closing to opening. If the element is not here. Holy crap. That one took me a bit. 9 more minutes. A phrase is a valid palindrome after. How much did I do so far? 0. A phrase is a palindrome if after converting all uppercase letters into lowercase letters and removing all the non-alphanumericals, it reads the same forward and backwards. Okay. We just have to lower this. We have a left and right pointer. Left equals a 0, length of s. Minus 1. Wow. Left is less than right. If left is alpha, if it's false, then we just move left. Because we don't want to compare that. Right, it is alpha is false, then right minus equals 1. Because we don't want to compare that. Else, elif left this should be s dot left. This should be s dot right. If s left is not equal to s right, if the left is not equal, we return false. Otherwise, else we left plus equals 1, right minus equals 1, return true. If is alpha is false, if is alpha is false, what is it breaking on? It might be the spaces. What? I lowered it. Oh, I forgot to store it here. Six minutes. Why would that? How is that false? Is it alpha? How do you check is? Is alnum. Never seen that function before. Holy, what can we possibly do real quick? Merge case word list. Insert merge intervals. None of these are fast no more. Climbing stairs. Yeah, I got another candidate coming up in like 2 minutes after this challenge. N equals 2. There are 2 ways to climb to the top. 1 plus 1. Yeah, so if... So what is n? N could be 1. So if you're at 1, n equals 1. Like there's only one way to get there. So if we could do n minus 2 n minus 1. So if n is actually equal to 2, we return 2. If n is equal to 3, we start n minus 2 at 1, and here we have 2. So pretty much all we need to do is return. So how many times can we get to... Bro, I think I'm trying to solve this bottom up. Oh no, this one's... I won't solve this in time. What can I solve reasonably? Merge 2 sorted list. Okay, this one's possible real quick. So we're given while list 1 and list 2. Should be the first return the head of the merge linked list into one sorted list. So we have our sentinel equals node, just like a random node, and then we'll do next head equals sent. Then we'll do left or top equals, we're gonna try to do sort them in order. So we'll do float infinity if list 1, if list 1 is none, else list 1 dot value. If top and bottom, if list 1 bottom, if top is less than bottom, do something. If the top is less than bottom, what we're going to do is head dot append I gotta clutch this one. Head dot append the top, else, or head dot next equals top, head dot next equals bottom. Otherwise we do head equals head dot next. Here if we move we'll move the top, so we'll do list 1 dot equals list 1 dot next. Here we'll do list 2 equals list 2 dot next. That'll work if it's even here, I think. But then there's just some cases gonna break. Equals Head equals head dot, wait. Top is less than bottom. Then the head dot next. Oh no, it's a value. Equals list 1, list 2. Okay, that solves it on one of the cases. There's an extra. I can't clutch this. Okay, chat, how much did I solve? It's ending. How much did I solve? Let's see. Then we got the next candidate up. 1. Okay, I started like 45 minutes ago. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 14? Tragic. I thought I'd get more. Alright. Okay, we're getting the next candidate in. Give me a sec.